Hello, friends. Podcast. First one in section 6.2 in the AP Stats book. Uh, section is called Probability Models. The big thing for us is to understand the basic probability rules. And these are the simple ones that are the foundation for the more advanced ones in the next section. So let's make sure that we really get this and can apply it to the problems that we're going to look at. So here they are. Rule 1, pretty straightforward. Every probability has to be between 0 and 1. 0 means there's no chance that the outcome happens, and 1 means there's a 100%. It's going to happen every time. S is the sample space. Again, the list of all the probabilities of all the outcomes in an event must add up to 1. If it adds up to more than 1, you've clearly made a mistake. If it adds up to less than 1, you've probably left some possibility out. Two events are disjoint or mutually exclusive if they can't happen at the same time. So, for example, I can't pick a card that is at the same time a heart and a spade out of a deck. So those two events are mutually exclusive. It does not mean the same thing as independent. So that's important to keep in mind. And so the first of these rules is this. If I have disjoint events, the probability of one or the other happening is just the sum of the two probabilities. So if the probability of getting a heart is 1 out of 4, probability of getting a spade is 1 out of 4, and the probability of getting a heart or a spade is 1/4 plus 1/4, which is 1/2. And then the other thing that you really want to know is this complement rule. We've already sort of mentioned it a few times, but the complement is the probability of something not happening. So if the probability of getting a heart is 1/4, the probability of not getting a heart, in other words, the complement of that, is 1 minus 1/4, so 3/4. So complement, it's also called a knot. There's a number of rules, but we use this all the time to do these problems. The fifth rule in this set is the independence rule. So this gives us a mathematical rule that we can follow to establish if things are or are not independent. So let's just look at an example. We have this P problem. You should pause and read this in the book or read it right on the screen in front of you. But you can see I have two events here. M being the event that the male contributes to G gene, and F being the event that the female contributes to G gene. And so the probability, if these are in fact independent, of both of them contributing the G gene is 1.5 times 0.5, which is 0.25. So that's just a rule that can be used to prove that things are independent, or if they tell you outright that two events are independent, I can use this rule to find the probability of both occurring at the same time. And this rule, they point out, and I'm really just talking about it in the context of independence, but if they don't talk about independent, you can't use this. So the one example we talked about, talking about drinking soda and eating pretzels, those events are clearly not independent because one makes you more likely to do the other. So this multiplication rule would not apply. I recommend that you read example 6.19 on page 427 in your book for an example of this rule being misused. And I want to just point out this one thing right here. This disjoint events cannot be independent. If A and B are disjoint, then the fact that A occurs tells us that B cannot occur. So if you just think about that in terms of what this formula says, there cannot be an A and a B if the events are disjoint. This number has to be 0, and so any two numbers that are multiplied together are not going to equal 0 unless one of these is equal to 0, which is counterintuitive. Here in your book on page 431, you've got a good summary of all the terms and concepts in section 6.2. In the second part of this podcast, I'm going to just go over some of the examples to actually apply these ideas.